Well, welcome back to our next unit on dealing with chemical reactions. The next series of lessons that we have are all about what happens when chemicals come into contact with one another and whether or not a reaction occurs, how can we identify it, and then as we get into more things about this whole unit's about starting to write out chemical equations and reactions, and then eventually being able to predict products and identify what types of reactions are occurring. So this particular one's a real quick and easy one. It's just about how do I know if a chemical reaction has occurred or not. I put two things together and something happens. Is it chemistry or is it not chemistry? So this is basically the four types of evidence that a chemical reaction has occurred. So pretty straightforward here. Just to keep in mind, review that we've got two different kinds of things going on. There's chemical reactions and then there's physical changes. Both of these things can cause something that looks new to be produced. The whole idea here is that sometimes chemical changes or chemical reactions don't look like much, and sometimes physical changes look like a whole bunch is going on. And so it's important to have some kind of strategies for being able to identify the difference. So the key with a chemical reaction, all these things on here describe chemical reactions or chemical changes. Number one, something new has to be produced, has to be a new chemical compound, and new chemical compounds have changes in chemical properties. They may also have a change in physical properties as well, but the big idea is that new chemical compounds have new chemical properties, things like reactivity, being toxic or not, being flammable or not, those sorts of things are the things that end up changing. Again, sometimes physical properties change as well, or oftentimes they change, which is lucky for us, but they don't necessarily have to change. We can talk about some examples later. Generally, chemical reactions are a little bit more difficult to reverse than a physical change. Many physical changes are simply changes in size, shape, or texture, or maybe a change in physical state, like heating it up, cooling it down, making it a solid, liquid, or gas. Usually with chemistry, once a chemical reaction occurs, it doesn't want to go back to its original state. Again, not always, but sometimes. And again, sometimes it's hard to tell. For example, these two pictures that are on here, one of them is a chemical change, and one of them is a physical change. They both kind of look like reactions, but really only one of them actually is. It turns out the one on the left, the combustion reaction, is actually a chemical reaction. The one on the right, even though it looks like chemistry, is really just dry ice melting. It's really not that exciting. It looks like chemistry, but it isn't necessarily. So there's four signs, and that's kind of what the rest of the video is, the four signs of chemical reactions. So number one, most obvious, easy to identify, is a big change in color. Not even necessarily a big one, but a change in color of some sort. Typically, if you've got the physical property of color before and then the physical property of color afterwards is different, then chances are pretty good that something new has been produced. Again, this isn't always true. So if you have two colored liquids that you add together, like a yellow liquid and a blue liquid, and you mix them together and, ooh, it's green, that's probably not actually chemistry. That's just physics, actually. That's just a change in those chemical reactions. But something like this, where you've got a blue liquid poured into a yellow liquid and it's yellow, something different there is going on. Or like the rusting, so to speak, of copper pennies, or even burning a piece of toast. These are changes in chemical properties, but they're as evidenced by a pretty obvious change in color. Okay, second one is, and these are in no particular order, but the second one is called precipitation. Precipitation in this context actually refers to the formation of a solid from when two liquids are combined, or from two other things are combined, and you get some sort of a solid that falls out of it. Precipitation also means rain or snow, but has a slightly different meaning in earth science or weather context than it does here in chemistry. So typically when we're talking about this particular reaction, we've got two clear liquids that come together, and we get some sort of an insoluble product, some sort of a solid form that looks a little bit cloudy. It's something that's a little bit different there than was there before. Like you see, you can see this one on the left here. It's this kind of yellow, muddy-looking stuff that forms. It's definitely something funky is going on there. Typically, when you get these sorts of solids that are formed, we can recapture them and figure out what they are through filtration. You just run it through a really fine filter paper, and you can capture that solid and figure out what the solid is. Keep in mind that formation of a solid through freezing, which is a physical change, is just a phase change. So that's not what we're talking about here. We're not talking about freezing it. We're talking about two clear liquids and poof, something cloudy and solid and gross looking appears. That's precipitation. Okay, third one is formation of a gas. Another one of our big types of evidence that something going on is that there's a gas formation. Sometimes this is big and fast, and sometimes it's small. So sometimes the gas that's formed is like the one in the top right, where it's fizzing. Just a little bit of bubbles is forming, not necessarily a whole bunch going on. Sometimes, like in the bread, we just see the evidence afterwards that a gas is formed. That's what all those bubbles were that's in there, was CO2 production, carbon dioxide from the yeast that was in there. And then sometimes it doesn't even look like gas at all, like smoke, or even it looks more like evaporation evaporation. So it doesn't necessarily look like a gas is being produced, but it could be there. A lot of times disappearing mass, it looks like that. Like, where does all the log go when you burn it? A lot of times that's because most of the log has been turned into gas, carbon dioxide and water vapor, and has gone up into the air. Keep in mind that one of the cautions here is that formation of steam, water vapor, is probably a phase change. That could just be causing from evaporation of water from a liquid to a gas, but it depends. So you've got to be a little bit careful even with this one. And then the last one is change in energy or change in temperature. So typically these are pretty obvious. Something gets warm or gets cold. We call these things endothermic and exothermic. Exothermic are the easy ones to identify because you touch it, it feels hot. Endothermic can be a little tricky. That means it absorbs energy. So the cold packs that you use, the kind where you actually pop the little bubble and all of a sudden it gets cold, that's an endothermic reaction. It's absorbing heat, so it actually feels cold to you. The other type of endothermic reaction means you actually have to add heat to it. So baking, for example, is an endothermic reaction. You can't get a cookie to bake on room temperature. It has to be in a warm, 400-degree oven or 350 or whatever it is. Cooking a piece of steak is an endothermic reaction. That can be confusing because the steak feels hot or the piece of bread feels hot when it comes out of the oven, but that's sort of leftover. It's not the reaction that's occurring. It's the fact that it had to be absorbing heat in order to get that reaction to occur. The last thing that's a little bit trick is sometimes that change in energy can just be the production of light. It doesn't necessarily have to be accompanied by heat. If you're used to fire as a way of producing heat, producing light, obviously that's hot as well. But things like glow sticks are something that produces energy. It releases or changes its energy state by releasing light, even though they're cool to the touch. They're not cold, they're not absorbing energy, but they're not warm either. So there's the four. Your four signs of a chemical reaction: color change, precipitation, change in gas or production of gas, effervescence, or a change in energy. Keep in mind that one of the fifth one, the kind of one that does this, it's definitely a sign, is the change in smell, a change in odor. Like, damn, that was definitely a chemical reaction. That kind of goes along with the concept of effervescence or production of a gas, but I don't emphasize that one because I don't really want you sniffing things. Kind of a bad idea, right? So beware of your flatulent reactions, and I will see you in the next lesson.